Hey everybody, welcome to Math with Ace, focusing on statistics today. We're going to be talking about standard deviation and how you would calculate standard deviation step by step, and then how you could use Stapplet. Standard deviation is not something that is very friendly to calculate step by step. It's something that when you go out into the real world and become a statistician, you are going to use a computer to calculate this for you instantly. The process of calculating standard deviation step by step helps us get a picture of what we are actually measuring. Standard deviation of a sample is most typically what we're going to be assuming. We are assuming this data is a sample of something from a population. The formulas for standard deviation of a population versus the sample differ. Let's talk about the formula really quickly. The formula for standard deviation of a sample is found by taking the square root of the sum of every x value minus the mean squared divided by the sample size minus 1. Standard deviation of the population is found by taking the sum of every x value minus the population mean squared divided by the sample size. Okay? So we are often assuming that we are dealing with a sample. When we calculate this using our computer, it's going to calculate it for a sample. The main thing to consider here is we're talking about degrees of freedom and degrees to vary versus the n and n minus 1. We're not going to focus so much on that. We're just going to talk about how we do these calculations, okay? Standard deviation measures the spread of your distribution. It tells you how far away each value is from the mean. We use different notation below. Standard deviation of the sample is represented by an S. Standard deviation of a population is represented by a sigma. It's a Greek letter, lowercase. But before we calculate standard deviation, we actually calculate variance, and variance is the squared distances from the mean. So if you see S squared or sigma squared, these refer to the variance, which tells us how far the data is, the square distances are from the mean. So if we're talking about the distance from the mean, we need to calculate the mean. So our first step is going to be, I've created this table for us to help us organize our results, and I'm only dealing with 10 data points here. More likely, you're going to be dealing with a lot of data points, which is why a computer is very helpful, or a calculator is helpful in this situation. But the first thing that we're going to do is we're going to list each of our values, and we're going to use that to help us calculate the average. So we have 2, 2, 3, 3, 4, 5, 5, 5, 5, and 6. And there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 values here. So to calculate the average, we're going to add 2 plus 2 plus 2, no, 2 plus 2 plus 3 plus 3 plus 4 plus 5 plus 5 plus 5 plus 5 plus 6, and then we're going to divide all of that by 10 to get the average of the sample. Said 10 and I wrote 6. Okay. So we're going to have 5, 10, 15, 20, 25, 30, 40. If we add all of those up, 40 divided by 10 is 4. That means that the average, the balancing point, is 4. If you added all of those numbers up and divided by however many numbers there are, you would get 4. Let's take a quick look at the distribution really quickly. If we have the numbers 2, 3, 4, 5, and 6, we had 2 2s, we had 3 3s, we had 1 4, we had 4 5s, and 1 6. And the calculation tells us that the average is 4. What we're then going to do is determine how far on average each of these pieces is from that mean. So in our next column, we're going to take each value minus the mean. The mean is 4, so we're going to do 2 minus 4. We're going to do 2 minus 4, 3 minus 4, 3 minus 4, 4 minus 4, 5 minus 4, and 6 minus 4. Now, a lot of people will automatically put the bigger number in the calculator when you're subtracting. The order matters because some of these values are below the mean and some of these values are above the mean. And that matters, the sign matters. So 2 minus 4 is -2. 3 minus 4 is -1. 4 minus 4 is 0. 5 minus 4 is 1. And 6 minus 4 is 2. If I was to sum this right now, -2 and -2 is -4, plus 2 more negatives is -6. And then on the right-hand side, I have 1 plus 1 plus 1 plus 1 plus 2 is 6. So I have 6 negatives and 6 positives, which would get me to 0, which tells me nothing about how variable this distribution is. It tells me nothing about how far each distribution or each point is from the mean. This is why we square the data. If you notice in the formula, you'll see the squares. This is why we square those. We square them so that we can make them all positive so that we get a value of how far away they are from the mean. Okay, so now we're going to do each value minus the mean squared. That means -2 squared, -1 squared, 0 squared, 1 squared, and 2 squared. -2 times -2 is +4. -1 times -1 is +1. If you do not use parentheses in your calculator and you put a negative sign 2 squared, it's going to tell you -4. That's because your calculator is squaring first and then making it negative. That's not an incorrect answer. That's an incorrect input. 0 squared is 0. 1 squared is 1. 2 squared is 4. And now I can sum all of these. So in the formula, that uppercase sigma means add all of these. So 4 plus 4 is 8, plus 1 is 9, plus 1 is 10, plus another one is 11, plus another one is 12, plus another one is 13, plus another one is 14, plus another one is 8, or plus another 4 is 18. So the sum of every value minus the mean squared is 18. Now we're going to divide that by however many there are minus 1. There were 10 values. 10 minus 1 is, so n minus 1 is 10 minus 1, which is 9. So the standard deviation of the sample is going to be the square root of that 18 over 9, which is the square root of 2, or roughly 1.414. What that means is each value on average is 1.414 away from the average. So that's saying about right here. Now we have some that are closer, but we have some that are farther away, which is where we get that value from. So calculating the standard deviation takes steps. The variance was 2 before we square rooted it. And then when we square rooted it, we get 1.414. So you find each value, find the mean. Each value's distance from the mean. Square it, add that up, divide by the sample size minus 1, and then square root it. So it's many steps, many places that you can go wrong. However, this gives you an idea of you are calculating how far each value is on average from the average. Let's pop over to Stapplet now to calculate this. Okay, so this is the number of FaceTime calls. I went ahead and entered the raw data. It was the 10 numbers 2, 2, 3, 3, 4, 5, 5, 5, 5, and 6. Put them in. You can use commas, spaces, semicolons, and then I begin analysis. Here is my dot plot. And then right below it is my summary statistics with my standard deviation underneath the SD. So it calculates it for us right away of 1.414. So the technology makes it super easy, but the step-by-step calculation is what really gives us the idea of what we're doing. We're finding the average. We're finding how far each value is from the average. And then we're squaring it so they become positive. Add that, divide by the sample size minus 1, and then square root it to get back to a single unit value. Hopefully this helps you get a grasp on standard deviation. Thanks for watching, y'all.